Identities relating to square roots. What are identities? Identities are certain true values, and we've already done exponents in our earlier classes or previous classes, and the same laws they apply to irrational numbers as well. The first law of exponent, what was the first law of exponent? The first law of exponent stated that a raised to the power m into b raised to the power m, if the powers are same, I can multiply the bases and take the power to be common. Here the power is replaced by a radical. This under root sign, this is known as a radical. And if I write it in the form of exponent, it will take the form half. So under root a means a raised to the power half. So going by the law of exponent, root ab means ab raised to the power half can be split up as a raised to the power half into b raised to the power half. This is very important in simplification of irrational numbers. Root a upon b, under root of a upon b means a upon b whole raised to the power half can be written as a raised to the power half upon b raised to the power half. Third, a raised to the power half plus b raised to the power half into a raised to the power half minus b raised to the power half. In the form of radical, it is written as root a plus root b into root a minus root b is equal to a minus b. Which identity have we used here? Here we have used the identity a square minus b square. Let me show you how. See, this is written as a raised to the power half minus b raised to the plus b raised to the power half into a raised to the power half minus b raised to the power half. Let us recall the identity that a square minus b square is equal to a plus b into a minus b. This was one of the identities that we have learned, that the difference between the square of two numbers can be written as the product of the sum of the two numbers into the difference of the two numbers. Similarly here, if we are given the sum and the product, the sum and the difference of two numbers as a product, if we are given the product of the sum and difference of two numbers is equal to the difference of their squares. So root a plus root b into root a minus root b, this can be written as root a whole square minus root b whole square. As I told you, a raised to the power, this is a raised to the power half whole square minus b raised to the power half whole square. Using the laws of exponent, if I have one power over the other, the powers are multiplied. So half into 2 will give you 1, and here also half into 2 will give you 1, and we finally result in a minus b. Coming to this, follows from the previous rule only, because this will become a square, this would become a square minus b raised to the power half whole square, which will give you a square minus b. The third one, the third is based on, we know that a plus b into c plus d. If I have to expand this, I will use the distributive law. What is the distributive law? A multiplied with whole of c plus d plus b multiplied with whole of c plus d. So, it will be A into C plus D plus B into C plus D. Following this rule, root A is multiplied with whole of C plus D and plus root B is multiplied with whole of C plus D. Multiplying root A with root C plus D will give you root A into C, and again going back to the first law. Let me explain this to you more clearly. Root A plus root B into root C plus root D. If I expand it using distributive law, this will be root A into root C plus root D plus root B multiplied with root C plus root D. On opening the bracket, I will get root A into root C plus root A into root D plus root B into root C plus root B into root D. Again go from the first law. From the first law here, we know root A into root C can be written as root AC. Root A into root D can be written as root AD. Root B into root C can be written as root BC, and root B into root D can be written as root BD. So, we have the same result here. Before I discuss the last point, let us recall all the identities, the square identities that we have also done previously. The first one, which we have already used here, we have used it here, that the difference between the square of two numbers is equal to the product of their sum and difference. A square minus B square is equal to A plus B into A minus B. Second, the whole square identities. A plus B whole square is equal to A square plus B square plus 2AB. So, this identity will be applying here. Root A plus root B whole square is equal to root A plus root B whole square will be equal to root A whole square plus root B whole square plus 2 into root AB. And we know root A whole square is A, root B whole square is B plus 2 root AB. So, we get this property. The third identity, root A minus root B, or simply whole square, will be A plus B minus 2 root AB. Let me see in the next slide. If I have to apply the identity, I will apply it to simplify my calculation. As we can see in the example, the first question, 5 plus root 7 into 2 plus root 5. So, using which identity can I solve this? Using the identity root A. Here I will use root A plus B into C plus root D, and will solve it using distributive law. 5 will be first multiplied with this entire expression. If I multiply 5 with this entire expression, I get 5 into 2 plus 5 root 5. Then 7 will be multiplied with the entire expression. I'll get root 2 root 7 plus root 7 into root 5, which will give you root 35. 5 plus root 5 into 5 minus root 5. Here we'll use the identity a plus b into a minus b, which will give you a square minus b square. Hence, we are using the same here. Here we are using the identity a plus b whole square equal to a square plus b square plus 2ab, and the same thing we have applied here. A square plus b square plus 2ab. Now we come to the most important part of operating with irrational numbers. How to rationalize the denominator of a rational number. It's very important to rationalize the denominator of an irrational number, because whenever we write an irrational number, it's very convenient to find the value of a number if its denominator is rational. Before I move on to, let me show you with the help of an example. Suppose I have an irrational number 2 upon root 3. Rationalizing the denominator is very important because division becomes simpler if I rationalize the denominator. Rationalizing the denominator means making root 3 rational. How can I make root 3 rational? Root 3 is an irrational number. I can make it rational by multiplying it with root 3 again, because I know multiplying root 3 with root of some other number will not give me a rational number. But multiplying root 3 by root 3 means squaring it. Squaring it means removing the radical. Removing the radical. Root 3 is nothing but root 3 raised to the power is equal to 3 raised to the power half. Now, if I want to remove this half, what do I need to do? I need to multiply it with 2. That means I have to raise its power to 2. Raising its power to 2 means multiplying 3 raised to the power half with 3 raised to the power half. So, I can rationalize the denominator or convert an irrational number to a rational number only by multiplying the same number, the same irrational number. So, multiplying the numerator and denominator by root 3. Let us see what do I get. I get 2 root 3 upon 3, because root 3 into root 3 will give me 1. Let us try another example. Suppose I have to rationalize the denominator of this. Obviously, I'll multiply the numerator and denominator by root 7, so that in the denominator I get 7. This is about a denominator with a single term. If the denominator has a single term, we can simply multiply by a single term and rationalize the denominator. But what if I have an expression like this? Suppose I have 1 upon root 5 minus 1. If I simply multiply by root 5, let us see what happens. If I multiply both the numerator and denominator by root 5, let us check what happens. I'll get root 5 upon, multiplying these two, I'll get 5 minus root 5. Still, my problem is not solved. It is not resolved because still I am having an irrational number in the denominator. Let us see which identity I can use to resolve my problem. My question was 1 upon root 5 minus 1. If I use the identity a plus b into a minus b equal to a square minus b square, my problem will be resolved. Let me see. If I consider this to be A and this to be B, now to get rid of this radical sign, this is my A minus B. If I multiply the denominator by root 5 plus 1, that means A plus B. The product would be root 5 whole square minus 1 square. Now, to remove the radical, I had already A minus B and I have to multiply with A plus B. But since I am doing this thing in the denominator, I have to do the same operation in the numerator as well. So, what do I get? I get root 5 plus 1 upon root 5 square minus 1 square. So, I get root 5 plus 1 upon 5 minus 1. So, I get root 5 plus 1 upon 4, and hence my denominator has been rationalized. Let us work with this example. 5 upon root 3 minus root 5. This is A minus B. Simply remember, if I have A minus B, I have to multiply with A plus B. So, I have multiplied with A plus B, both in the numerator and the denominator. So, in the next step, I will get A square minus B square, that is root 3 square minus root 5 square. Root 3 square minus root 5 square will give you 3 minus 5, and hence in the denominator, I will have minus 2. But I do not write minus 2 in the denominator. What have I done? Here from this step, this is 5 upon root 3 plus root 5 upon minus 2. I have done one more step to remove this negative sign from the denominator, because if I rationalize the denominator, P upon Q form, Q will not be equal to 0, not less than 0. We try not to write the denominator as negative. So, what I will do, one more step, I will multiply both the numerator and denominator by minus 1. If I multiply both the numerator and denominator by minus 1, I will get this value, minus 5 upon 2. Now, my denominator has been rationalized. Let us try this question. 1 upon 2 plus root 3, multiplying the numerator and denominator by 2 minus root 3. So, I get 2 minus root 3 upon 1, which can be written as 2 minus root 3.